Hello, welcome to my easy statistics. Please like, share and subscribe the channel. Contact me for data analysis and training. You can contact me through email or WhatsApp. How to do contrast coding for categorical independent variable. Contrast coding is a method used to represent categorical variables with more than two levels in statistical analysis. It involves creating contrast coding that represents meaningful comparison between the levels of the categorical variable. Unlike dummy coding, which creates binary indicator variables for each level, contrast coding creates contrast codes that capture the specific comparison of interest. For example, in this case, we want to find the impact of exercise on weight loss. Weight loss is a dependent variable, exercise is an independent variable, where exercise is a categorical variable with four levels: swimming, running, cycling and aerobics. We want to do the contrast coding like this. We are creating three contrast codes. Why? Because we have four categorical variable. When we have four categorical variable, 4 minus 1, 3. So we need to create three contrast codings: C1, C2, C3. And in C1, you can see contrast coding is between swimming plus running versus cycling plus aerobics. In C2, we have contrast coding for swimming versus running. In C3, it's a contrast coding between cycling versus aerobics. If you see C1, swimming and running, we have given 1 by 2, 1 by 2. In cycling, we have given minus 1 by 2, minus 1 by 2. If we add, it will become total as 0. Here also you can see for C2, swimming 1 by 2, running minus 1 by 2, add it will become 0. Means the total of each code must become 0. And the negative code is taken as a base group. Now in C1, cycling plus aerobic is taken as a base group. Compare with swimming plus running. In C2, running we are compared with swimming. In C3, cycling versus aerobics. Now the same coding is done in SPSS and we will do the analysis. This is the SPSS data where we have weight loss, which is a dependent variable. Exercise is an independent variable. We did the coding as we discussed earlier here. Right, now we will do the analysis. Analyze, regression. In this linear, take dependent variable as weight loss and take C1, C2, C3 as independent variables. Click OK. Now you can see the model summary and the ANOVA. We have significant value 0.00, which is less than 0.05. Important point is to discuss the coefficients, that is unstandardized coefficient values. First we will discuss the constant. In this regression output, the intercept is labeled as constant and its value is given as 7.991. This means that when all categorical variables, that is C1, C2 and C3 are at their reference level or 0 level, the estimated mean weight loss is approximately 7.991 kilograms. Now let us see how we got this value. This value we got with the mean of the mean weights of swimming, running, cycling and aerobics. Swimming 6.070, running 9.593, cycling 9.738, aerobics 6.563. I'll show you how we are going to get this. You must go to data, split file. In this, organize output by exercise. Click OK. Now go to analyze descriptives. Now we are going to see the descriptive value for weight loss. Now if you click OK, now we are going to get mean weight for swimming category, it is 6.070. For running, it is 9.59. And for cycling, it is 9.73. And for aerobics, it is 6.563. It's the same values I have used. These are the same values which you got in the SPSS. Now, if we add them all and divide by 4, we are going to get 7.991. This is the same value which we are given for constant. Now, let us see for C1. C1 is a comparison between swimming plus running versus cycling plus aerobics. This negative coefficient suggests that when comparing the combined effect of swimming and running to the combined effect of cycling and aerobics, there is a decrease in weight loss of approximately 0.319 kilograms. However, this coefficient is not statistically significant because the p-value is 0.6657, which is more than 0.05. So this is not significant. Now let us see how we got this value minus 0.319. If we take the mean values for swimming, it is 6.070, running is 9.593. Add them and divide by 2, we are going to get the unweighted mean of swimming and running. For cycling and aerobics, if we add the two values 9.738 plus 6.653 divided by 2, we are going to get 8.1505. Take the difference between them. That difference is minus 0.319. So this is how we are going to get the unweighted coefficient for C1. Let us see for C2. C2 is a contrast between swimming and running only. This negative coefficient indicates that when comparing the effect of swimming to running, there is a decrease in weight loss of approximately 3.523 kilograms. This difference is statistically significant with a p-value of 0.001. Means there is a significant difference between swimming and running. If you see only swimming and running, swimming is 6.070, running is 9.593. Means there is a more weight loss in running compared to swimming. So if we take the difference between these two, we are going to get to minus 3.523. The same value we got for C2. If you see for C3, it is a comparison, contrast between cycling versus aerobics. This positive coefficient suggests that when comparing the effect of cycling to aerobics, there is an increase in weight loss of approximately 3.174 kilograms. This difference is statistically significant because the p-value is how much? 0.005. Now how we got this value? It is a difference between mean weights of cycling and aerobics. You can see cycling we got 9.738, whereas aerobics 6.533. Okay. The difference is 3.174. Means there is more weight loss in cycling compared to aerobics. The difference value is the unstandardized coefficient value 3.174. So this is how we are going to do contrast coding. I'll show you one more example where we have different method of contrasting. You can see in this contrast coding, we have C1, C2, C3, where we are comparing between swimming, running, cycling versus aerobics. So swimming 1.4, I have taken 1 by 4, running 1 by 4, cycling 1 by 4. If we add this, it will become 3 by 4. For aerobics, it is minus 3 by 4. If you add total, it becomes 0. So C1 is a contrast between swimming, running, cycling versus aerobics. In C2, we can see swimming, running versus cycling. In C3, contrast is between only swimming and running. So basing on your research, you can decide what contrast you want for C1, C2 and C3 analysis. I hope you understood this video. Thank you.